Okay, in this video I want to talk about the this pointer and also talk about static members again. Now for non-static member functions, the compiler passes the object's address to the function as a sort of hidden argument. You can see I have an instance of an entity called demo entity. I do demo entity.setMember5, for example, so I have some setter function. Now that member function invocation can be interpreted as you do the setMember function, and then the compiler is going to pass the object's address to that function as a sort of hidden argument. You can see the address of demo entity, and then I pass that value 5 in again. This hidden argument, the object's address, is available from within non-static member functions as the this pointer. Here's an example of the this pointer. Every object has an address, and the this pointer contains that address, right? Every object can refer to its own address via the this pointer. Now with some other programming languages such as Python, the self keyword is used instead. Okay, I have an example of a function, void GameStats. So the class is GameStats and then the function is setLevel. It has an integer parameter, level p, and then these two statements are equivalent. mLevel, so some member in the class, you set that equal to level p, or you can do this and then do the arrow operator, mLevel is equal to level p. Those two things are the same. And the reason why we haven't used this pointer up until this point, why we haven't needed it to access the members, is because it is implied, right? So you don't have to use it, but in some instances it is useful, as we'll see in upcoming examples. And that is when you want to be explicit. For example, you can have a parameter and a member name. Both of those can have the exact same identifier. And because of scope rules, the formal parameter name will actually be used instead of the member that you want to assign to. And that can be confusing, so what we do is we use the this pointer to refer to this particular object, and then we get the member from that, and we then assign the parameter to that member. The this pointer is only accessible within non-static member functions of the class or struct. Remember that non-static member functions require an object to be invoked. Static member functions don't have the this pointer available, since they do not require an object to be invoked, and they don't have the hidden argument containing the object address. Static member functions cannot access non-static members. Okay, non-static member variables form part of an object or instance. Since the this pointer contains the object's address, you can think for a second what's going to happen when we dereference that this pointer. Well, dereferencing the this pointer will yield the current object, and we'll see an interesting example of this later on in the video. In this example, I use the entity struct again. I have an integer member which I'll set to 0 by default in that struct. I have a void member function called setMember. It has one formal parameter, int member. And you can see what we are trying to do in the body of this member function. Basically what we are trying to do is we are trying to assign the parameter to the member variable, but because of scope rules, this is actually not going to happen. All we are going to do in the body of the function in this case is we are going to set member, which is the formal parameter, equal to itself. So basically we are doing nothing here, nothing meaningful. So in main, I instantiate entity, I create an object, entity1. I do entity1.setMember, I pass in an argument, a literal of 400, and I do console output entity1.member. This is a struct, so we can just print it out directly. Build and run that, and all of a sudden we get 0. Remember, I set the member to 0 by default. The main issue here is naming conventions. That is why I often recommend that you end the parameter with a p or something like that, and your members start with an m, for example an m and an underscore. Now I'll actually just take a step back and show you how we can fix this problem. Previously this was ambiguous, so because the names are the same, the name of the parameter and the member, and because of scope rules, it's actually going to use the parameter name as I explained. So actually not going to assign to the member, you are simply going to assign the parameter to the parameter. Now this is unambiguous. Okay, so we use the this pointer. Now as I mentioned in previous sections, you can dereference this, and that's going to yield the current object. And then you can do the dot operator and then do the member. But the syntax is a bit busy. I'm just going to undo. We use the arrow operator instead. Again, this is a pointer, so it contains the address of the current object. What is the current object? Well, back in main, again we have entity1. So we call setMember on entity1, and so entity1 is going to be the current object. This is going to store the address of entity1, in this case where we call this function. Not right here, because this again is just a blueprint for when we actually invoke that setMember function. but here where we invoke the function, this is going to contain the entity1 address. That is sort of passed in as a hidden argument, as I explained in these slides. So we do this, the member access operator, and specify the specific member, and we can do the assignment with the parameter. This time if I build and run it, it prints out 400. Now what I'm going to do instead is I'm going to change this member here. I'll postfix that with AP. Then this should work fine. And the reason why it works fine is because it uses the this pointer in the background basically, so it's implied. So even though in this example we don't use the this pointer, it's sort of implied. As I mentioned, the current object is basically passed in as a hidden argument. We access the member functions using some member access operators such as dot or the arrow operator if it's a pointer to some object on the heap or the stack. Remember, these are not static member functions, so they operate on an object, and an object, just like a variable, has some address in memory. Okay, so in the case where I want to be explicit, use this pointer, and from that you can access the current object's members. Okay, that's it for this example. Another example is where you want to do a check to see if the object you are affecting is the current object or not. Okay, for this example I have the entity struct again. I have this member function called compare. It's just a void function. The formal parameter looks like this. It's a reference to a constant entity and it's called other. So in the body of the function we don't want to change whatever this is referencing. That is why that is const. Then I have this if else statement. If this, I use the this pointer right here. If this is the same as the other object. Remember, this is going to be a reference, so use the address of operator. We apply that to other. And in that way we compare the current object with whatever object it is that we pass in as an argument. If they match, or if it is the same object, then we print this out. The objects compared are identical or are the same. Otherwise, the objects are not identical. Alright, so in main, I instantiate the entity struct. I have entity1 and entity2. Then I do entity1 dot compare and I pass in entity1. If you build and run this, you should get the objects compared are identical. I'll pass entity2 in as an argument. And this time if I build and run, the objects compared are not identical. This was just a simple example, but it is useful in various situations. In many of my examples, I introduce some of the more seemingly complex syntax that you can run into when programming in C++. If we think about the this pointer, it stores the address of the current object. So what's going to happen when we dereference the this pointer? Well, that will heal the current object. So what does this mean? Well, it means that we can write a function that returns the current object or a reference to the current object. And that is what this next example is going to demonstrate. And then also some of the more interesting syntax that you can see. That seems a bit complex, but as usual, if you take a step back and you look at the implementation, you'll see that it's actually not that complex. And for this example, I'm using the class GameStats again. In the public section, I have the constructor GameStats. I'm going to define that outside of the body of the class. Then I have two functions, setCurrentLevel and setCurrentRoom. In the private section, you can see we have two members, two integers, level and room. And we're going to use these functions, setCurrentLevel and setCurrentRoom, to set those members. And then I also have a helper function, toString, which is simply going to print out what those member variables store, so the state of the object. Okay, the constructor is right here. It says the level to 1 and the room to 1, and it prints out the default constructor invoked. Then I have this function. Now notice with these functions, the same in the body of the class. Look at what it returns. It returns the type of GameStats, but it actually returns a reference to the type of GameStats. So again, looking at the definition of the setCurrentLevel member function, it returns a reference to a GameStats. In the body I have the level member and I set that to the level parameter, so we'll pass in an argument. What will the function return? It will return this right here. This again will contain the address of the current object, and we are going to dereference that. That is going to yield the object itself, and then we return a reference to that. And the same thing with the setCurrentRoom function. It has one formal parameter, roomP for room parameter, and then in the body we set the room member equal to that room parameter, and we return the current object again. We basically return a reference to that. Now in toString you can set the text however you want. All I'm going to print out here is current level, I have a tab, and the level member. On the next line I have current room, a tab, and then the room member. Then in main I instantiate GameStats. I create an object called game. Then from game I simply do the toString function, and then I can do game.setCurrentLevel, and I can do game.setCurrentRoom. Same concept that we had before. Let's say we have some text-based adventure game. We want to keep track of the level and the room as well. Let's say our levels have different rooms. We keep track of those. So here again I'm setting the current room and the current level. Then I print those members out again using game.toString. I'll just build and run this to see what we get. We'll just get that default constructor invoked just to see, okay, we have constructed this object. The default constructor will set those to 1 by default. Then we go and change it, and then we print it out again. So we change those successfully to 5 and 9 respectively. But you can have some interesting syntax with this. You can actually do it like this. So what I'm going to do is, I'm going to take a step back and then do the dot. And you'll see it shows up in the IntelliSense. What we do here is we do game.setCurrentLevel, then dot again, and then setCurrentRoom. If you understand the definition of these functions, then you'll get what's going on here. But let's just look at this again. So I do game here, right? Game is an instance of GameStats, so that is an object. Alright, let's go to setCurrentLevel. The statement right here is simply going to assign the level parameter to the level member. And then what do we return? This here is a pointer and it's going to contain the address of the object, the current object. What object is that? It is game, because we are calling the function on this game object. Alright? But again, that is a pointer, so if we dereference that, what happens? Again, this is dereferencing. Well, that will actually heal the object itself, that game object. So we return a reference to that back to the calling function here. So once this section executes, what are we going to get back? What is it going to return? Again, scroll up. It's going to return a reference to what? To game. And that's why we can do the dot operator here, because again, this is going to yield basically a temporary reference to this game object. Then we do dot, and of course from there on we can do setCurrentRoom, and we set that to 9. So the syntax might seem a bit confusing, but if you take it step by step and look at the definitions, you'll see it's quite logical. Again, this is dereferencing. We are not returning a pointer. At first, if you look at this, you might be thinking, how are we now returning a reference when this is supposed to be a pointer? Well, remember we are doing dereferencing, so this is essentially going to yield an object, and we are going to return some reference to that object. I actually don't recommend that you do it in this way, so I'll undo a couple of times. And then here I just have this for reference. It's better to do it in this way because it's more readable at a quick glance. And as a programmer, if you're not familiar with the definition of those functions, then you might think, well, what's going on here, right? But in this example, I thought I'd show you this more seemingly complex syntax. It's important to understand the this pointer because we're going to use it again in upcoming lessons where we do operator overloading and various other things. So try and take your time and understand it. Again, it seems like a really abstract and weird concept, but hopefully from all of these summaries and all of these examples, you'll see it's actually an easy concept to grasp. This is really just a pointer to the current object. Okay, so that wraps up this lecture. I'll see you next time.